just divide this whole number by 34. We have to divide it up into smaller units. Alright, so now how many times is 34 going to 28? And that we cannot also do, so it'll be 0, because 34 is bigger than 28. So now we move on to the next unit, so 289. So because we are in a different unit, we are in the hundreds place. So that would be like, how many times is 34 going to 200? So that's kind of what we're looking at. So if we did 34 times 8, we will get 272, and that is the closest to 289. So we would put 272, and we are subtracting because we are still dividing. So we do 9 minus 2, and just like everything else, we are dividing this into small units. So we have 9 singles minus 2 singles is 7 singles. 8 minus 7 is 1. Alright, and 2 minus 2 is 0. Alright, so now we are moving on to another unit. So we bring this 0 down and 170. So again, we are in the hundreds place, 170. So that would be like, how many times is 34 going to 100? But it is 170. So 34 times 5 is 170. Perfect. So that fits perfectly. Oh, and I forgot to say we put the 8 up here to represent that 8 rods can go into 34. And since we did 34 times 5, we put that 5 up here. In other words, 5 times 34 is 170. And we subtract, and we get 0, 0, and 0. So, to go back to the definition, you start with some things and give an equal amount of things to a fixed number of groups, and count how many things end up in one or each group. So we are counting how many things end up in one group. So since we divided this problem up into multiple groups, we did start with the 2, the 8, 9, 0, and we wrote down the 0. So we want to count how many things end up in each group. So this would be 8, and this would be 5. In other words, we get 8 rods and 5 singles to give the final answer. And to answer the question again, we divide the problem up into sub-problems because it's more efficient, and and we are working with 4 different units. We have singles, rods, flats, and supercubes. Since we are 4 different units, we have to make sure we divide it up into 4 steps. Thank you.